Well, thanks for coming, everybody, to the Utah Go meetup. We're kind of mixed and matched. Mariah does a lot of the backend stuff, but I'm ostensibly running it. Clint and I, but Clint is not here.
We're getting the speakers and talking and introducing everybody.
Yeah. So we're just going to do a couple of quick things and let Thom take over. So Slack, there's dedicated channels in the Forge Utah Slack. The links here are not accurate, I've learned, but there are links posted to the chat for this meet right now if you want to join on either the Slack or Discord, and we'll update those.
You can ask me, and I'll send you emails as well.
Yeah.
So just find me, and we can send you emails.
But there's dedicated channels on there for both looking for a job and trying to hire. So I encourage people to look at both of those channels in Slack. There's a paper call for women who go. I just couldn't find the one for Utah Go.
That's because Utah's there isn't one for Utah Go. It's only women who go, but we're pulling from the same speaker pool for both.
I see.
So I can update that. One day I won't have a conference.
Nope. For a year. Speaking of that, so anyway, there's papercall.io for women who go, and or just post if you want. Like, we have a lot of Weave speakers, and that's fantastic because we do a lot of Go at Weave. But I would love to get more people with more diverse use cases. I've said it before, I'll say it again. If you have even the shred of an idea of what you think would be a good talk and you're not sure it's interesting, it's probably interesting, even if it's not complicated. If it's just something you're passionate about or some piece, that seems arbitrary or simple, like, it's probably a good talk if you're passionate about it. And I'm happy to help people work on content and come up with a talk. I want to see more diverse speakers. Speaking of that conference, we'll plug it right now. Go West is coming up. It will be hosted here in October, I don't remember the exact date.
22nd? How do you not know what day you're speaking, Carlin?
It's on my calendar.
October 22nd, here in this building from 10 to 5, and it's hybrid, but everybody's come in person because it costs more. It's free if you go online. It costs money if you come in person, so.
That's not a great pitch.
We'll feed you if you pay.
There you go. Come in person because you'll get food. There we go. It's fun. It's a lot of cool speakers there. I think it's our second year doing that, and I'm excited to do it in person this time because we did it all online last year.
Great content. People like Carson Anderson, prolific speaker, will be attending and speaking. I'm pitching you.
Thank you. I appreciate that. I can't pitch myself, so. So that's it. Next, I'm just going to hand it over to Thom and let him take over, and he's going to talk about full stack code gen. I think we talked him into doing some Weave specific stuff. Is that right? Like, you were going to hide some, but now we got some in there.
Yeah, I'll kind of just share where we're at in Weave. Describe a little bit about the state of where we're at, and yeah, it's exciting. It's fun.
Cool. So real world use case a little bit at the end. Nice. All right, take it away, Thom.
Okay. So guys, I think that code generation is going to be one of the most significant technological advancements in software as people adopt it more and lean into it more. And so this stuff gets me super excited. I think probably there's going to be a time where we just see models of data and we dictate to a computer how we want that thing to be turned into an application, and it'll be great. So let me share this with you. Okay, full stack code gen, strategies and tools. So at Weave, we use GRPC and Go. And coming from a front end, well, actually, yeah, when I started at Weave, I hadn't even gotten any experience with TypeScript. So yeah, I didn't know about like type safety or anything like that, let alone generated clients and servers. And so there was a lot of learning experiences for me over the last couple of years that I've been here. So I'm going to talk about some of these strategies that I've kind of started to adopt for myself when thinking about designing systems with generated code, and then also some of the tools. And this is also maybe more a talker about how to displace an entire engineering department and subsume all of their salaries. So what is code gen? That's where we'll start. We're going to kind of get I don't think there's a universal agreed upon definition, but I think that we can get one that's sufficient for the needs of this talk. Then, in terms of full stack code generation, I think APIs is where you're going to get the most bang for your buck. And so we're going to spend most of our time there. And then near the end, we'll look at how you can do more specialized things either on back end or front end using some of these tools. So code generation, as software has advanced, we've got in different layers of abstraction, right? We start with hardware, then we got machine language, then assembly, then higher level languages. Now in Go, we don't ever have to worry about memory or heaps or stacks or hardware or any of that stuff. We are concerned with this communication protocols like GraphQL or RPC, and we're definitely concerned with data models and business logic. So CodeGen, I don't think that these frameworks are CodeGen. I wouldn't say that they are. I would say these utilities that you can use are more in line with CodeGen in my mind. I would say CodeGen is a meta layer on top of language-specific implementations that allow us to abstract particular problems from our daily workflows. And so as we go through some of the stuff in this, you'll see maybe why I describe it like that a bit more. So first thing, yeah, we're going to start with the API layer. This is definitely where you get the most bang for your buck, I think, especially in the distributed microservice architecture, where you've got a whole bunch of clients all consuming from a network of other clients and servers, and the servers are updating their data and changing their models, hopefully not breaking contracts, but adding new data that the clients would have to consume. And so generating a lot of that, taking that problem and just creating a automatic workflow that gives you a deterministic output every time. That's, you don't need to test it because there's no possible human error there in terms of the wiring. So you get a lot of benefit from it. So some of the lessons learned are API first thinking, understanding what the domain knowledge that you're working with is, building pipelines with your code gen, and making sure everything is extensible. So some of those benefits I was starting to get into, consistency, compatibility, stability, and testability. When you're generating a client, whether it's gRPC or HTTP, yeah, you abstract an entire layer of human error with wiring up the IP address and unmarshalling and all that junk. And then beyond that, when you are generating your code from an API, you get a single source of truth that everything can lean to. So instead of duplicating this across multiple services, we have the contracts abstracted away from the services, and that creates a lot of consistency and makes things much easier to maintain. There's a talk by Michael Brizik. This is, I think, one of the first things that our late and great CTO Clint shared in Edge Hour. This is probably one of the best tech talks that I've ever seen. So if you've only got time for one talk today, stop and go watch this one. I really think everyone should watch that. So then the next thing is understanding that the code that you're generating when you're thinking about the API, when you're doing API first thinking, you are generating the domain knowledge of your app. So generated server code in gRPC would be at the center of a hexagonal design pattern. One of the things that we ran into was adapters for the generated code to make Go structs that would be at the center of your app. And then as things needed to be developed, we ran into what I liked to call adapter hell. It was a lot of unnecessary work, extra confusion, and potential for error, with virtually no benefit. And then when you're generating clients, you could put them in the ports and adapters. And one of my dirty little secrets is oftentimes I won't write an adapter around my API if you follow the practice of you don't break contracts. It's very easy to get away with that. Okay, then with pipelines. So ideally, your code gen tools are Atom-like and composable. This allows us to create pipelines where at each layer we have complete control. And this will also be, I'll talk about extensibility, but that's one of the big reasons for this. Here you can see kind of a flow, and this is very similar to what we've got at Weave today. You have your API contracts with Proto or Swagger. You run a linter to check if it's wire safe or not, or compiler safe, or whatever type of linting you want to test on it. Supposing that passes, you start the generation. That generation then outputs, in our case, we're using GRPC. We get the server stubs, which of course we have to implement, and then we get the clients. And once with GRPC, we use GRPC Gateway to get the HTTP handlers, and from there we will get Open API docs, and then further generate clients for front-end web apps to use the TypeScript or just wire straight into a fetch client. With extensibility, one of the reasons you want to make everything extensible is because you don't want to be constricted. And I guess the best quote I ever heard about this was on Twitter. Someone said, frameworks take away the full expressive utility of a language. I think there's something to that effect. Basically, when you're generating code that you have to implement, you don't want to take away the expressive utility of that language, right? So if you're generating an HTTP handlers instead of just straight up implementing an HTTP server, then the developer can still go in, plug in their own middlewares. They can circumvent the certain routes. They can do whatever they want within the language, within what the language permits them to do. So with, and this is kind of what we do at Weave. Right now we're generating backend GRPC server and clients to talk to them. And then we also have a route of generating documentation and TypeScript for our web clients. And with this, it is all tied into the CI/CD. The DevX team has done an awesome job with this. So basically, you will get nice big alerts if you're breaking a contract. If you're not, then it allows you to create the generation. Then all the downstream clients will be updated with the updating of packages. And it's beautiful. So API tools. I talked about GRPC, CCS 123. I'll get into this a little bit here, high level stuff. So 3 steps to it. You define your proto. Right here, you can see this is kind of what the syntax looks like. You implement the server. So you put your business logic in here. For your greeter function, you might have a format print line that says hello. And then you connect a client, and the client will dial into the server. Bing, bang, bong. You're good to go. With Gateway, it's easy as 1, 2, 3, 4. There's an additional step in here that is implement the HTTP handlers. Again, these are generated handlers that can be implemented in whatever type of router or multiplexer with whatever type of middleware you want. And there is a little bit of abstraction here. I'm not showing, I guess, everything, but this is basically the minimum amount you need to do to implement an HTTP server with gRPC gateway. This gRPC server endpoint is a specially formatted string. But what happens here is, again, you pull down the latest generated gateway code from your Proto generation, and then all of the new handlers for your HTTP API are automatically implemented, and there's all the, they'll be taken in, marshaled, and then proxied onto your gRPC server. And you don't have to touch it. It's great. And in terms of strategy, it's API first thinking. So we got to check there. We're we're separating domain knowledge from particularities of a protocol. So we're good there. It's extensible and it's pipe lineable. Here's an example of, so with that, you can further annotate your proto definitions to basically describe your API, right? You can plug in whatever type of information you want with the Open API and Swagger spec. And this is what the, well, yeah, I'll just share a little bit of what the output looks like. This is not a very pretty UI. This is mostly just for housing and sharing our Swagger docs. But we get this for free. We define one proto schema. We hit a button, and then we get all these nice HTTP documents as well. And so that the fact that HTTP doesn't have reflection like other protocols, you get a lot. You get to go around that quite a bit with code generation. Then you can check out the gRPC ecosystem. They've got a lot of stuff for middlewares and Prometheus. And there's also plugins to generate GraphQL. So theoretically, you can have a completely protocol agnostic gateway, right? You can service your RPC, your gRPC, your GraphQL, your HTTP, whatever else you want. And it all comes back to the same business logic housed in your gRPC server. So that is the that's the gist of the API stuff. I can share with you guys a little repo that I started so that you can, if you want to play with this stuff, you can clone this and start messing with it, right? In here, you have oh, not that one. In this repo, you've got it set up to do your Go, your gRPC, your gateway, your Open API, and your GraphQL. In this repo, though, the GraphQL isn't fully generated with a client yet. I wasn't able to finish that yesterday when I was cramming to prepare for this talk. So you can also, if you would like, put a PR request and make this playground a little bit nicer. And that'd be very cool. So then in terms of backend, we want to aim for a lot of the same things. We want to reduce boilerplate, ensure consistency and compatibility, speed up development, make life better. So at Weave, on the schedule team at least, we're using SQL C a lot. And it certainly makes dealing with Postgres much nicer, in my opinion. And I can share an example of what that looks like, you guys. Some of the neat things you can do with it. Let me share a different screen. So I've got 4 different queries here. I've got an upsert statement for a user model. I've got a search users statement, a select user, and a delete user. I'm just writing the PostGrest logic with a little bit of specialized syntax so that SQL C will know um, what my variables are. So with this statement, we have a Postgres conflict to check if the ID exists, and if it does, then we'll do an update, thereby getting us a method we can use for creation and updating. Here we do a little bit of Boolean or logic, right, to check if we want to search this thing or this thing. And this allows us, you could see how you could extend this for more advanced search capabilities. There is, I guess, maybe the syntax of how you work with this type of generated function is a little bit different than you might otherwise write in Go. But you can see it would generate some queries for you. You can, let me actually pull that over. And I want that one. So you can see my search users right here. This is the name of the function that I've generated. It's going to return many things. And this is the query it's going to run. So I've specified 4 different variables. And then when I use it, I'm going to use the generated struct that it's given me and call the function with context and the parameters that I want for my list users endpoint on my gRPC server. And then it returns the SQL C users, which also, fun fact, will just come straight from your migrations. So if I change this table and add an email or something and generate again, then that user would have the email field on there as well. And the nice thing about generating structs that are implemented, especially if you make sure you're just doing additive stuff, is if there is, well, in the case that there is something breaking, the compiler will catch it rather than it being obfuscated by, just plugging in bad types, right? Or writing bad structs. And then if it's not a breaking change, then you don't have to futz with the boilerplate of feeding it through different layers to get it to the client. So it's a fun thing to do. And then another fun little benefit I think that I enjoy is when I'm writing tests for these, I can run it, I can expect the query by the name that I've put inside the SQL C annotation, basically. This guy right here. Right there, right? So this is a silly test, right? Because if I select 1, I wouldn't get 2. But the point is this right here, I don't have to write the entire query out to match that expectation when I'm mocking my database. And this is um, ex extremely convenient, especially if you do test against your database. Um, make sure your functions are operating the way that you want them to. So SQL C is very cool. However, you don't have to use crazy add-ons to get code generation. You can use, of course, you can use Protobuf to write your own extensions. I'm surprised there's not already more for things like NSQ or Kafka, but you could certainly do that, right? And if you had the shape of the data you're dealing with, and then you say, hey, generate my Kafka client, bing, bang, bong, right? You have the structure ready to go. However, you don't need to use Protobus for that. You can certainly use just straight Go. Go is actually good, really good for this with embed and templates. You can do quite a lot. And here at Weave, there's actually a few projects that leverage this quite heavily. John gave a really good talk demonstrating how to use these tools. So certainly check that out after you finish watching a one by Michael Brzik. Then with the front end, so I think probably one of the biggest benefits of this code gen is that we're extending the boundary of protocol, right? We're going from backend to front end, and we're sharing the same source of truth, the same contract. And so now our gateways, if I could be a little poetic, are also bridges, right? It bridges the gap between both ends and unifies developers. So that's great. So where do we go from here? I think there's one of the things I had attempted to do yesterday. I had a few hours, so I spun up this repo. My goal was to get a singular proto def. Oh, thanks. Let me stop and share this. Boom, boom, boom. So my goal with starting up this this project was to get an app that I could basically generate the database, and then the server, and then the API, and then also the client. So obviously I didn't accomplish that yesterday, but I think that it's certainly doable. So I think that's the possibility, right? Considering that you could annotate your code or your protos in such a way to specify the database structure and also the scalar values in, something like JS. You could theoretically make an entire app that's ready to run with just annotations and data models. So that's I think the aspirational goal with that that repo. So feel free to contribute and add to it. I did want to call out a honorable mention, PostGrest. This is also not CodeGen. This is a service. It it reads your database, and then it serves an API, a REST API, from that for you automatically. So I threw together one with some Bible text. So if you're interested in the Bible, you can check out this this API. It's got the Hebrew text and the Greek text, and that's the interesting thing about it. But the thing is here, the API is not. I wouldn't say this is. I didn't have any control over the output of the API. I didn't get to decide that. I didn't get to design the domain knowledge. When I search for a book, I have to use specific query language, right? And let's see if that works. Basically, it's the query language you have to use is specified by the project PostGrest. And then I can't extend that API unless I actually implement the API and then make a proxy app around it. That would be, I guess, the way you could. However, it is pipelineable because we have all of this Swagger documentation. So one thing here is you could potentially make generated UIs to plug in the syntax, basically UIs that conform to the syntax of the search patterns that are dictated by the PostGrest. So yeah, that's I think at a high level, all the things that I've learned and thought about for the last few years of my life. Yeah. Questions, comments, concerns?
I am muted, so if you've got questions, you can. But did we throw one in the chat?
Oh yeah. Okay. Good question. CRUD tests. Actually, yes.
Can you read that question for us because we can't see it and the video recording won't answer?
Yeah. So what about CRUD tests and unit tests? That is a great thing to bring up. We actually get a lot from just generating these Swagger docs, right? You can automatically import and create a collection in Postman to prefill. You get a Postman collection for free with one of these. And supposing that you've annotated the, let me pull up another example. Boom. Yeah, because you still want to test that the service works, right? Even though that the protocol layer is abstracted, you still want to make sure that the actual service is working like you expect. Let me share a window. I think that I have an example of. Okay, so this is where you would annotate your HTTP. And if you're trying to test with CRUD, I imagine that you might be wanting to do that with HTTP. You can, I don't have it in this repo, but you can add example bodies, and then you can also annotate like right here. So wherever this user is plugged in, we're going to have this example. When you're generating Postman collections, you get all of this Swagger doc info baked into that collection right off the bat. And so you would need to still make sure that, you know, if you're running against a development environment or production environment, you need to make sure that your environment is set up correctly so the data matches with things that were plugged in there. But yeah, you actually get a lot of that kind of handed to you. It's not all done exactly, but you get most of it for free.
Thom, do you feel? Can you hear me?
Who's that?
That's Clint.
This is Clint. That's Clint.
Clint, you're gonna make me cry, man.
Sorry, Thom.
Be brave.
Brave.
Do you feel like as this progresses, I know it's all leveraged on top of gRPC, you're using a lot of open source tooling and wiring it all together, which is incredible. But as this progresses and you add more generation and you add more features, are you essentially just building your own framework?
No.
Instead of using what already exists?
That's an important thing to call out, yes. And the reason we're not is because every component of this pipeline is extensible, right? Let me go back to this picture. I'm going to just share my whole screen. So and at least that's the goal, right? Is like like when you build it, like some frameworks, you can't operate outside the framework, right? You have to make a whole nother app to even do anything, because the framework constrains you from doing bad things, in its opinion. With the code generation, you can bake in all of the preferred conventions and strategies, but if you ever need that escape hatch, right? Like with the code we have at Weave, we have these HTTP gateways generated for us, but we also have the handlers, right? And generating the handlers allows us that escape hatch so that we can implement them however we need to. And that actually is very beneficial for rapid development, and it doesn't constrain us to that that same, I guess, opinionated approach that frameworks have. So I think that's the main reason why I'd say it's not building a framework. It's theoretically different.
Very cool.
I've got a question on the, if you can hear me, I hope so. So like, I see you've got, right, you're paired, you delete user, update user with the individual requests, request response types, I think.
So, oh yeah, so are you wondering like how this is working?
So when we've looked at it in the past, it feels like either we have to choose either kind of gRPC Proto conventions or REST conventions, because especially with the request response, per RPC request response structs that you're encouraged to make, it ends up making the REST have like some weird nesting and act really different than a typical REST service. And I mean, I've seen all the Google generated stuff, and it, as a new user, it's a nightmare, and it in no way resembles REST. And so that's kind of where we've gotten stuck, and we've kind of chosen a weird combo.
So actually, yeah, we've at least on my team, on the schedule team, we are, and this is not a good example. I kind of threw this together hastily, but we are attempting to follow the best practices as defined by the protobuf community, I guess, as well as making everything RESTful. And so, like, I guess for the way that I approach it is thinking about it in terms of resources. Like if it's a user, right? I'm dealing with a user resource, and so I'll make the user message. That would be like the base of my resource. And then from there, I will follow the protobuf guidelines for my list, get, create, update, and delete. And we can implement REST that it's pretty much follows that somewhat seamlessly, I'd say.
That line
I guess
31, Tom.
Like with the individual requests, you're nested in a user or a request. Like
So a 50, I like 50. 50 is a good example of, I think, kind of where with stuff I've been doing today. On line 50, you have basically the route is users, and then you have a parameter right there, that user.id is the user message with the ID thing, and that allows you to use REST style parameters, or you can go through and you can do whatever you need to do with parameters or arguments inside that endpoint, that REST style endpoint, and you can map that back to the gRPC payload. I think that, at least in my experience, and Tom's done more of this than I have, seems to be the closest, the best way to get that REST functionality, right? Is to kind of go through and do those kinds of mapping parameters and things like that. And there's a lot.
This JSON blob would, right, in normal REST, you would expect I'm posting a user object, but this generates to I'm posting an object with a user key that has a user object.
And you can also, well, I mean,
Well,
you can just do
if we look
again
at the-
instead of- yeah.
Yeah, it has a user key with a user object. Yeah. Okay, I see. I see what you're saying. Yeah, actually, I ran into that today with when I was doing a pair session, and they're like, "Why the heck do we have this key and then the data? Why wouldn't the data just be that data?" So yeah, I think you're right. It is a little bit different. Not exactly the premium REST that you would, I guess, want. But in terms of trade-offs, I would say I'd take it.
I think you're right. I think that's any code gen. The wider and more broad that code, like the protocol gets generated out, inevitably you find languages and situations where it feels less natural. Like if you use a lot of the big cloud SDKs, in certain languages it feels very natural, and then in a lot of others it feels like a different language. Like the Go SDKs for Azure feel like C# SDKs, like because they're generated off of C# or some document where it's designed first for C#. And then, yeah, it works in Go, but it never feels like Go. Like, this is never going to feel...
Right.
And I don't know where the right line is. I tend to just be like, well, learn your learn structs a little bit better, get a little better with your types. Like, we're going to have a bit more type nesting for the generation benefits. But, yeah, I don't think there's a way to get them perfect both ways.
Like, we haven't actually done this, but we've thought about, like, doing the mapping layer. Like right now we're handwriting our handlers, so it feels like REST, and then translating that to gRPC. But we've wondered about starting with like the Swagger Open API definition, generating Go handlers from that, and then handwriting the gRPC to REST conversion there. So, I don't know.
It depends on what you want to do first. You're trying to go API, like REST API first versus gRPC that happens to also give you REST, right? And I think you're right. You might choose your way if you really want to like make that the premium experience. I think one of them's got to be the weirder one,
right?
A lot of extra work.
Yeah, if you want to centralize the source of truth, you have to start with one, right?
Yeah.
So Tom, in your flowcharts, you always started with, what did you call it, a API contract that you lint and then generate a proto, but you've always demoed the proto. What format is this API contract in?
So that, it is proto. We're defining the contract with proto, but when you get to different languages, right, in JavaScript, it's going to have to be JSON or TypeScript, and when you're in Go, it's got to be a struct, right? So I think that, in my experience, I like using Proto as the source of truth. It gives you the utilities needed to do everything that I've wanted to do, and it's somewhat concise comparatively, like when compared to like Swagger docs.
Okay, I thought you said that you were generating these API contracts into Proto. So what tools are you using to lint to Proto?
We use Buff for that. So this is what a Buff configuration looks like. You can have your linter rules. I think these are all the rules we were breaking with our old gRPC packages, and so I had to lint to accept those, and then you have all your plugins in this type of gen YAML file. And this is this makes generation pretty straightforward. The only painful thing about Proto is it's difficult to find examples of anything online. So yeah, you just hunker down and get ready to search if you need to find out how to do something.
Hey, Thom, a question that someone put in the chat that looked interesting. I don't know if you guys have gotten there yet, but are you generating any interactions directly to databases with this yet?
So with like migrations and stuff, the things that I've used is like Goose, and that just does the up and down migrations. And I haven't really gone beyond that in terms of database stuff.
But I mean, like, when you make your CRUD, will it auto-generate database interactions, or is that still manual?
Yeah, that part's still manual, and that's done with this SQL-C.
Yeah.
And I'm not sure. I think that it's possible to get to that point, but also I'm kind of conflicted because I'm not sure if that really is the best approach. Because it might be that specific tools need specific generation around it. So if someone has a better answer,
I created some SQL annotations on models in Proto that would change the how it generated depending on what you put. Like for instance, if you set it to, hey, I'm storing this in Vitesse, it would generate Vitesse specific stuff, and you can annotate fields.
Yeah, that'd be super cool if the data storage layer was just abstracted as well, right? Like you can abstract all the protocol layers of communication and the data layer. That'd be super cool.
We're just waiting for Clint to open source it so we can use it.
No.
It's on the Weave server. I don't have access to it anymore.
I find that I wonder a bit about that. So is the Proto your API? Should it also define your storage mechanisms, or is it really about communication? Right? Like the API at one level is about how things talk to each other, and sort of it kind of is almost a separate thing. I'm not saying you shouldn't, but I wonder if you're mixing, two things that.
It would definitely need to be optional.
Yeah. Well,
For simple
yeah.
cases, it'd be great, but for complex cases, it couldn't express everything you need.
Yeah, I agree with that. I think I'm not 100% sold if like the definition for your API should be the same as the definition for your database. But I do wonder if there is some way to reconcile that. I do like the idea of.
Don't you hate mapping Proto objects to your database objects over and over and over? It's terrible.
Yeah, it is. That is garbage. That's flaming hot garbage to deal with. I do like the idea though of like you don't have to worry about you can change, right? Like with this, you could go from HTTP to GraphQL, and you don't have to change your code. You just change the generation mechanism. The idea of being able to do that with your data storage as well is quite appealing to me.
You could easily generate mapping functions. Like at a minimum, you could be like, and then pass your proto message and pass your database struct, and it's going to map everything as best it can. And again, for simple use cases, it would be nice to like add a field to your type in your proto and not have to go add it to any other code, like just have it use some generated function to populate, again, for basic use cases. Like as soon as you get complex relationships and all that stuff, it falls out. But for like simple cases, I agree, not going in and adding a field to a bunch of queries and stuff and just getting that all for free would be really cool. It's a line. That's an interesting line to walk and to figure out how to be composable and flexible, but not mandated.
Yeah, and I think that line also goes the other way too, whereas like you have these clients, these web apps that are built with GUIs, like graphical, like WYSIWYGs, right? And I think that's the wrong approach. I think you should start with the data and then generate the web app. And I wonder if you could, get something that goes both ways.
I've got a question on SQL-C and like the database layer. Does it support, like we do, and not everywhere, but we do, storing JSON blobs, or like how does it handle complex struct storage, or does it?
Yeah, I'm pretty sure it does.
Is a good sign.
Yeah, I don't know off the top of my head. I'm pretty sure that you can.
You should
I'm
be
pretty sure
able
that
to
you can.
use JSON at least, if nothing else. it has the PostGrest driver and will support JSONB as a column type. I don't know if it'll let you index on that, but it, well,
I'm thinking more of like, as we have some, custom scanner loader database SQL stuff that will marshal or unmarshal from JSON as it's going in or out. But if I'm using SQL C to generate from the database, it's not going to necessarily know, it can't generate that struct for me.
So, in some ways it can. So you have this override capability where you can specify Go types that will basically be, you're going to override the default thing that comes from Postgres with this particular Go type. I don't know if it would be able to do what you're talking about. That seems probably extensive.
Meaning like if it was JSON in that column and then converting it to a struct?
Yeah, like if it would be able to unmarshal and put it in. Yeah, I don't know if it would be able to do that.
He was paying the creator like $300 a month. So you could just ask him to do it and say you were.
SQL C?
Yeah.
I think we're still.
Actually, I think I was paying it personally, it turned out.
Your card?
Yeah, in the summer I was like,
but how
I'm a
does
sponsor. Oh, that's my card. Oh.
I hope you canceled that one, Clint.
I mean, I like SQL C.
It's an interesting idea. That of course brings up all the, like, what do you do when you get types that don't unmarshal, and like, I think it's really nuanced to like just having be able to store JSON blob and get some extra features around it in Postgres is fine, but like selecting that, selecting 1,000 rows each with their own JSON, and the one in the middle fails to unmarshal, like.
Well,
don't get that.
MySQL has JSON schema support, so I can enforce the schema. I don't know if Postgres does that, but
They do, and not Cloud SQL.
we do.
Okay.
Right, schema is important.
But if you didn't have, but again, yeah, this doesn't necessarily guarantee it runs and everything that has that.
Right.
You're right. You could work around it. I was just saying, like, it'd be a weird thing to suddenly have to solve. Like, I can get this row, but I can't get this part of this row. Like.
Yeah, that's where JSON schema support's relatively new for MySQL, and it's been awesome. Because we can do whatever complex validation we want,
That sounds awesome.
so that we don't have to create a bunch of extra join tables for whatever the blob is, but still have full schema.
Yeah, I like that.
Yeah, that sounds cool.
You have a make file in there. Can you do all this code generation locally, or is any of it dependent on your CI/CD? Even outside of this sample, like, do you have things that only CI/CD can do, or do you try to bake it all into local dev?
So with this example, I've got this generator. This is just a big bash script that pulls in different Docker images that I've made for some of this. That's what I've done it that way for this playground, just so that it would be easy to mess with each of the components as needed. And then each of the Docker files you can read. Wait, where did I put them? You can read each of the Docker files in the subfolders of the generator to see what's going on. In real life, you would probably still use Docker. You'd still Dockerize things and it'd be part of your CI/CD. So yeah, I can run this. I can run this locally. We'll try. Let's see.
Really get reliable, any kind of get really repeatable, guaranteed outside of CI/CD. Really tricky because you think you Dockerize it, and then there's always
Then somebody want the Windows laptop.
right, or the Docker's out of date or whatever. And so
Yeah.
we kind of came up with actually a service-based concept. So there's two. Right now you can commit to the main schema, and if you can get it merged, it goes to all the things. We're currently actively working on branch-based stuff. John's here working on that today. So you can get dev branches. And
Right now, John, are you working on it right at this very second?
probably.
I actually posted a PR for Carson to look at 7 minutes ago.
Yeah.
We're gonna review the PR for the last bit of this tech talk.
But the third thought was service, you have a schema gen server, or you have a generator service. So you have a tool that calls out to the service and says, hey, this, run the generation for me, spit back what I need, and I'll put it in a branch or zip it up and send it to me, because it's not that much, it's not that big. So we always had to abstract because it was impossible to keep everything up to date. But if you call the service, like you call the service and we change it now, and it's changed for pipeline, it's changed for everybody that calls with the client. Like you can't have out of date clients or configs.
We had to write scripts in Go just so that people on 3 different operating systems could run them easily.
Yeah.
Because it was a pain trying to keep Bash and Shell and stupid stuff.
Yeah, these guys wrote a Weave CLI tool specific to Weave, and then at first it was like keep it all local, and then no one updates it, and even like okay, we'll put something in the hound them to update it, even just like yes, hit Y to update it or whatever, but still people would run it with outdated code and it was like it doesn't work. It's like
Yeah. No, I think at service-based, that's the third phase. It's like, here's where I just edit it locally. I didn't even push. Like I just add some files, and I run the command line to, in our CLI, grabs it, sends it up to the generator service, and it spits back your generated code. And then it's.
Would you try to maybe use modules as the way of doing that too? Like you could have it spit out a new module version that you then depend on, or would you just have it spit out the raw code?
I want to make it as fast as possible local dev. That's my ultimate goal. I want to be like, I'm going to edit Proto, I'm going to send it to me, and it'll give me back the depths, and I can. The branch one's the fastest one. Is basically there now. It's like you can just push your branches all day, and you can reference them in your Go modules and whatnot. But
You said it updates the clients. Are you guys on a mono repo, or how does it update?
it generates the code. It doesn't update.
Yeah, so it doesn't automatically update. All the client has to do to update is install the package, right? Update the package. So yeah, it's actually a really nice experience, right? If you did break the contract, because even on the front end when you're using TypeScript, you'll still get compiler checks, right? And so you supposing you broke the contract and then you tried to put it inside your service, your pre-built checks would fail because the new API doesn't work. And I like that. I like that pattern, that workflow.
The local dev question with any gen is always the trickiest part.
So eventually your build system outlives what you can put on a laptop, and then you're.
Yeah, that is.
On 1,000 laptops.
Yeah, local dev is it's certainly optimized for production dev. When you need to make changes across different parts of the generation, it can be a little bit tricky. You've got them all separated in different services.
Is that all? Any more questions? I'm ready to clap and then end the recording. That's.
oh sure.